We've alluded to the important applications of being able to work with matrices and their inverses, and today we're going to take a look at one of the perhaps most important or most commonly known applications known as the Leontief input-output model. This is a Nobel Prize award-winning model that was created by Wassily Leontief as an economic model. And what it does is it explains how interconnected sectors, maybe manufacturing, agriculture, and some sort of services, how much they should produce in order to meet each other's demands. We often refer to that as the intermediate demand, because that's not really ultimately the point of that production. The point is usually to meet some sort of final demand, which could be the demands of a city for food production and perhaps electricity and different types of services and other functions. So in short, how much needs to be produced, or which we can refer to as a vector of amounts produced, one for each of the different sectors, is going to be the sum of how much they're required to produce to meet the intermediate demand, plus how much they're required to produce in order to meet some sort of final demand. So for example, if we were to say that perhaps maybe agriculture has to produce, and we usually measure this in some sort of dollar amount, because you can't really compare 1 unit of services to 1 unit of agriculture without there being a monetary exchange. And money is usually the easiest way to equate products to one another. So maybe they need to produce, let's just keep this real small, we'll say $100 of product needs to be created so that they can fuel the other companies that are needing their services. And maybe they need to produce $1,000 worth of product in order to meet maybe the demand of a grocery store nearby. And so in total, how much they produce, they would need to produce $1,100 worth of their product in order to meet the production requirements for the other sectors within that industry, as well as the needs of the grocery store. So let's go ahead and take a look at how we can construct this model. And that's really the point here, is to understand how models are built from an understanding of the underlying data. So what we have in this table is, along the columns, we have each of the 3 sectors that we're going to be considering: manufacturing, agriculture, and services. And along the columns, this is how much manufacturing needs to consume of each of the 3 services, manufacturing, agriculture, and services, in order to produce 1 unit of output. So for example, if this is measured in perhaps money, then I could say that in order for manufacturing to produce 1 unit of output, or $1 of output, it needs 50 cents worth of its own manufacturing. It needs 20 cents of agricultural product and 10 cents worth of services. So maybe they need to produce their own tools or their own utilities in order to run their plant. And maybe they need some agriculture for whatever reason. Maybe part of what they do is they manufacture, I don't know. Of course, I can't think of anything at the moment, but maybe they need services in order to have customer service and be able to talk with clients. So this can be thought of as one whole vector right here, corresponding to just how much manufacturing needs to consume in order to produce 1 unit of output. So that's similar for agriculture. They would need, for 1 unit of output, they would need 40 cents of manufacturing, 30 cents of services, and 10 of agriculture, and 10 cents of services. And services is very similar. Now, I'm going to go ahead and refer to these vectors as C1, C2, and C3. And to get a sense of how we're going to build this intermediate demand, because this really describes our intermediate demand. This is just how much needs to be consumed internally in order for production to take place. So the first thing that I'm going to consider is what would it mean, for instance, to take 100 times C1? Well, that would be 100 times all of the values in here, 0.5, 0.2, and 0.1. Now what we know is that we would require 50 cents of manufacturing to produce 1 unit of manufacturing. But what we're asking for is, what if we produce 100 units of manufacturing? Well, this means that we would need, we'll just say this is in dollars, so we would need $50 worth of manufacturing goods. We would need $20 worth of agricultural goods, and we would need $10 worth of services. So that is for 100 units. Now, in general, I could say that maybe we don't know what these companies need because we haven't yet considered the external demands, so maybe 100 units isn't enough to keep things working internally and then also to be able to meet a town's final demand. So let's just say that instead of 100, we're going to use X1. So X1 units of manufacturing is to be produced. That's something that we need to determine, multiplied by how much consumption is required per unit. Now that's only for manufacturing. I could do the same thing for agriculture. I could say that agriculture is X2 times C2, and so that corresponds to agriculture. And then I could also say the same thing for services, that they're going to produce X3 units of their product, and each unit of their product requires C3 units of input. Okay, now I want to know the total demand, right? So the total demand is going to be X1 times C1 plus X2 times C2 plus X3 times C3. Now let's think about what this would mean now that we put this all together. So if I just said that this was 100 and this was maybe 10 and this guy was maybe 2, then what that would tell me is that at least in my top row I would have 100 times 0.5 plus 10 times 0.4 plus 2 times 0.2. Well, remember what this row tells me, that this is how much is going to be required from manufacturing. The 100 times 0.5 tells me how much the $50 worth of product is required in order for manufacturing to produce 100 units. Similarly, for agriculture to produce 10 units, it's going to cost $4 worth of manufacturing. And for services to produce 2 units of its output, it's going to require, basically in this case, 40 cents worth of manufacturing. So this will tell me the total needed for manufacturing. The total manufacturing needed. And so when I take this product right here and I see that this is a scalar sum of 3 vectors, I realize that I could write this as a matrix containing C1, C2, and C3. And these are going to be 3 columns inside of this matrix here, multiplied by the vector containing x1, x2, and x3. And we are right here measuring our intermediate demand. And let's just go ahead and define x1 and x2 and x3. This is the number of units produced by the 3 sectors. Or we'll say industries. Okay, and these are the corresponding needs of each of those three industries. So we're going to simplify this. We're going to say that this right here, we're going to call that matrix C. And then we're going to call this vector over here, we're going to call that vector X. And so this product right here gives me my intermediate demand, which is the consumption matrix multiplied by the amount produced. And one thing to notice here is that the amount produced has to take into account the intermediate demand, which is odd that for the first time we've ever seen the output actually depends upon the output. How much you produce depends on how much intermediate demand there is, which involves how much is produced by each company, plus this final demand vector, which we'll call vector D. So this is just going to consist of, could be for each of these three sectors, we're going to have maybe, the city needs 500 units of this, maybe 250 units of this, and maybe 75 units of services. And so that will allow me to figure out what does X have to be in this situation. So the final Leontief, or Leontief, input-output model is of the form X is equal to C times X, the total consumption, plus the demand, the final demand required by the city or the whatever we are serving with this industry. So in the next video, we'll get at how do we go about solving for this vector X.